Hi, I'm Jose, and this is a technical demo of a multiplayer weapon system built in Unreal Engine, focused on networking, audio design, and debugging workflows. I separated the audio system into two layers. First, local-only sounds like mechanical clicks and shell drops, which are only played for the owning player to improve responsiveness and detail. Second, world sounds, like the gunshot itself, which are triggered via multicast so all players hear them spatially in the environment. The firing logic follows a server authoritative model. When the player presses fire, the input is handled locally for responsiveness, but the actual projectile spawning happens on the server through an RPC call. From there, the server replicates the projectile actor to all connected clients, ensuring consistency across the session. Finally, I use a multicast function to trigger shared effects like the gunshot audio, so every player perceives the same event in the world. In this example, every time I shoot, 3 spheres are drawn on the shooting client. Yellow represents the mechanical sounds, red represents the shell sounds, and white represents the actual gunshot sound. However, only the gunshot sound is replicated across all clients. In a crowded environment, like a combat scenario, those mechanical sounds can become irrelevant for the other player, but still consume resources, so they might not be worth replicating. You can see this clearly in this example, where only the white sphere is drawn on both screens. To enhance audio quality, I integrated metasounds for procedural variation. Instead of playing the same sound repeatedly, the system allows me to randomize parameters like pitch and asset selection. There is one metasound for the gunshot, another for the mechanical sound, and a third one for the shell sounds. Speaking of shell sounds, I decided this was a good opportunity to have some fun, so I created a small function that spawns the sound on a random position relative to the player. First, I store the necessary vectors in local variables. I also set all the offsets I need, and then return a randomized position every time. I kept these variables exposed in the blueprints for later fine-tuning. I also added a probability check using the math library, so the sounds don't play every single time. You might also notice that I'm using debug spheres. An important detail here is that I'm also replicating the debug state itself. I added a boolean variable called vDebugAudio and replicated it using getLifetimeReplicated props. This ensures that when the debug is enabled on one machine, it is consistently enabled across all clients. Without replicating this variable, each client would have its own local debug state, making the visualization unreliable when testing on a multiplayer behavior. Thanks for watching!